standard. If I have to take some metal out of the block to make the hole round and straight to maintain the proper clearances for the liner, I have to make this fatter.
Oversized liner.
Oversized, yeah, exactly. So if I take 10 thousandths out of the block, I got to add 10 thousandths to the liner, so it's a 10 over liner. Make sense?
Does that happen a lot?
Yes, quite often. So when you go, good point, when you go to do your rebuild, so you got all the components out of your block, just like we have there. And you take your block into the machine shop. Say, hey, I need it milled and rebored. He says, I got one for you. It's a reman block, meaning it was a customer who brought it in. The machinist machined it. He gave the other customer another block, kept his, machined it, put it in stock. You want a block that's ready to go, it's already done. Here you go. So the turnaround time is, you go in, you give him your old one, he gives you one that's already been machined. Does that make sense? Versus, okay, I'll have it back to you in a couple of weeks. You can't do anything because the block is the foundation of the whole engine. So you can't tell the customer, oh, it'll be a couple of weeks before your truck's back on the road. That's just to get the block back, not even for you to build it. That doesn't usually go over well. Okay. Now, so the larger the hole that we have to make in the block to get it round, the thicker or bigger OD the liner is going to be. Okay. Now, protrusion or liner protrusion is critical. So in this particular instance, this looks like a Detroit, I can't tell for sure. He's got the head bolts in and he's forcing the liner down seat in the counterbore. Okay? And he's got to measure with a sled gauge and a dial indicator how far the liner sticks up from the top of the block. That's called liner protrusion. Okay? So the proper protrusion gives the head gasket something to crush around. Okay?
Where is he measuring at?
So here's the top of the block. Here's the top of the cylinder liner. So what he would do is he would take the sled gauge and zero the needle on the block. Then he would lift it up, place it on the liner, and the difference between here, and this is going to be higher,
The top of the liner.
top of the liner, is the protrusion. So basically what your protrusion looks like that's your protrusion. The bit of distance the liner rides above the block. And it's adjustable by putting shims of various thicknesses in the counterbore and the liner to adjust the height of the protrusion. Yep. Does that make sense? So for example,
That's the one.
on a Cummins M11, protrusion for a new block with new liners, the minimum protrusion is 0.025 millimeters, or about a thousandth of an inch. Okay, the maximum protrusion is 0.122 millimeters, or about 5 thousandths of an inch. Okay, now because the liner on a Cummins has a little ridge of itself, if this part is riding flush with the deck, or slightly above it by a thousandth of an inch, there's enough for the head gasket to crush. So it gives you a range. In this case, it's not a lot. 1 thousandths to 5 thousandths. Now what happens if it's riding too high? We've talked about not enough protrusion, but what happens if it rides too high?
Doesn't seal?
Say that again?
Doesn't seal?
May not, or it's going to try and seal, and it ends up doing this. So I've got a little gap here. Okay? Now, some engines will even have minimum or maximum variance between the heights of the adjacent cylinders, the cylinders next to it. So I don't want a cylinder there at that height, and then I got a cylinder here, way up here, and then I got another cylinder way down here. I can't build a head gasket that can do this. They tell you don't snort these things, but they make it smell good. We got suckered by the Girl Scouts. What's that?
That explains a lot.
Well, it says non-toxic. 5 boxes of Girl Scout cookies the other day. That's toxic. That's horrible. It's cheating. 2 boxes are already gone. So every manufacturer will have you have a method for prepping the liner prior to checking it. It's not likely that you're just going to push the liner down in the bore and then check it. You'll have to have it clamped to seat it in the bore to check the clearance.
The O-rings don't want to push it back up, huh?
Hmm?
Because the O-rings kind of want to push it back
Well,
up.
the O-rings, yeah,
You're simulating the head.
yep. Some clamping force on it. Okay. So you're going to check that. Then the OEM will have you check the ID inside the liner again once it's pressed into the block because it may change a little. Okay.
It changes when you bolt the head down, like on a parent board block. A lot.
Yeah.
Like
Distortion.
that's another performance application.
Yeah.
The shims you put on the bottom there, they're like metal or
Yeah.
they're just like rings?
No, they're not springs. They're just very
No,
fine.
rings.
Yes, they're very flat pieces of steel and ring. And I've seen guys turn them around on a finger, and then they got a bloody finger because they're sharp. They're like razor blades. I just watched the guy. That's called negative reinforcement.
And those
Learned that in school.
they come with specific measurements? Or you
They
have
come
to-
in, no, they come in various size thicknesses. So you'll get it, if you buy an overhaul kit, you'll get shim kits in there that'll have shims of various thicknesses to set the protrusions of your liners. Now, going back to a low budget rebuild, you know, I need it done in 3 days kind of thing. Will the mechanic take the time to sink the liners, clamp them and measure them? Probably not. He'll sink the liners, put the pistons in, bolt the head up with the gasket, and hope like hell it stays running. Now, I don't know about you, hope is not a good guarantee. Okay, I'd rather have a little more definitive, are you sure this thing's gonna run? Oh yeah, we mic'd it, we measured it, protrusion, the variances, decks are flat, head's flat, valve recessions within spec. I mean, I could go on and on. Okay, and if you ever look at a build sheet, okay, like when my brother built racing engines, you're gonna buy a racing engine from him, you're gonna cough up about 100 grand. Okay, it better work. So he had a build sheet. Everything on that thing that was measured and the value was entered in with the specifications next to it. So when the customer got the motor, he looks at the build sheet, he knows it was checked because there's a value in there. And it's within spec. So then he cuts some check. Now there's no warranty on a motor. You don't warranty race engines. Because you don't know about the driver, man. He could zing the clutch, blow it up right before it gets the green flag to take his laps.
How do you pressurize that, the liner to?
How do you drive it into the bore?
Uh-huh.
Dead blow. A soft mallet. Some will have an installation tool that will, now when I drop this thing in, it's going to sink 3/4 of the way in to begin with. And some manufacturers will have a tool to go to the top, you just tap it in. Okay, you tap it in, you apply your clamping tools, in this case it's bolts with washers, you measure your protrusion. And when you're done, you take these out, do the next one, and the next one, and the next one. And when you're done with all 6, you know that head gasket's going to seal, because you've got the protrusions in spec.
So, on the protrusion, you can shim those liners, so you would go and, as long as it has the maximum specs within check, probably take the highest protrusion that was allowed, shim the rest of the liners to the highest one.
I wouldn't go highest.
Uh,
I'd go about medium, about mid-range. If I go too low, if I go to the minimum range of protrusion, I'd probably get a good crush, but I don't know. But if I go mid-range, I know I'm going to get a good crush.
But if one of them is protrusion, if the protrusion is at the, almost at the maximum.
Then I'd
tolerance.
take a shim out
Oh.
and I'd lower it.
But
Now,
that's, you can always do that, there's never
Oh,
a
yeah.
situation where it just, that's where you can't go any lower. or-
yes, there is. That's a good point. Thank you. So I take my block to the machine shop, right? And the machinist mills my head flat. And now that's the new dimension. But he takes and doesn't do anything with the counterbore, so it's its original depth. But now it's shorter because I took some machining off the top. Y'all with me so far? Now I sink my liner in here. And I can't get the protrusion in spec. I've taken all the shims out that I can, and it's still too tall. Now I got to go in, back to the machine shop, or I got to buy the tool and machine my counterboard down to establish the OEM depth of the counterboard, the original specification between how deep should the counterboard be. Because there is a spec for that. Right? Because that counterboard depth changes as I machine the block. Gets smaller and smaller and smaller. Now a good machine shop, or one that knows what's going on, if he takes 20 out of here, he's going to take 20 out of the counterboard to maintain the original spec set by the manufacturer. Now, they're not all good machine shops. Especially if you go in there and say, I need this thing like tomorrow, dude. And they're like, okay. There you go.
Right now.
Maybe. Most good machine shops will say, look, if you need it that much of a hurry, I can't help you. Because he's going to take his time with it because it's his reputation on the line, right? Not only that, he machines a block. You put it together, blows the head gasket. Hey man, you did something with that block, I keep blowing my head gaskets. And technically he'd be correct. So he's not going to take that chance. Okay. Again, poor planning on your part doesn't mean it's an emergency on mine. You need it like tomorrow, then go find somewhere else.
Go get a Dremel.
Right. Okay. So, going back to your original statement, yeah, there could be a situation where I can't get the protrusion within spec because my counterbore isn't deep enough.
I got a question.
Shoot.
To know how much shim can you have to put in there, do you have to put it this thing first,
Oh yeah.
and then okay,
You sink it and you measure it.
and then you go back.
And then you pull it out, you put your shims in it. Like if it's, so you pull the engine down from the OEM and you see that the original equipment, when they made the block, they had to put 4,007 inch of shims underneath the liner to get it set, right? So you pull the thing apart, you check the top of the block and it checks out okay. So you put 4,000 shims underneath it to start with and you sink it, only it's too high because the block is worn a bit.
Yeah.
So you have to pull it out, remove a shim or two, press it back in, clamp it,
It's a process.
measure it. Yeah, it's a process. See, this is why when you buy a Cummins Reman engine, it's $19,000. Because the guy took the time to do that. Now, you can go down to Joe Bob's engine shop and buy one for $7. Joe Bob just dump, 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 dump. Oh, it has some shims, so I'll put a couple under there anyway because,
Extra.
and he drops it all in there and paints the block, looks all nice and pretty, and he puts it together. Well, what are the specs on it? What's the running clearance? What's the, oh,
So you would have been
well,
instructed,
hand me my beer,
nothing but problems.
right?
So you would pull this out several.
You could pull it out
Just to get
several
it.
times, especially on a Detroit, because Detroit will say, no more than 3,000 variance between cylinders. So if I sink one and I sink two, and they're within 3,000ths of each other, then I sink three, only three's 6,000ths higher than two, I either gotta adjust three or adjust two, but if I adjust 2 to 3, I might take it out between 1 and 2.
Why wouldn't you just put them all in, measure them, write down what your findings are, and then pull them up and put them in?
You probably would.
That'd be the best way.
But you still may have to pull one, adjust, pull two, adjust, whatever. You might have a good day where you drive them all in and they're all within spec. Hey, I got the min-max and I got the variance. I'm a happy guy. I'm gonna buy a lotto ticket tonight. I've seen guys have to, they can't get them in spec, so they'll take 2 out of 1. They'll take cylinder 6, put it, sink in whole cylinder 1, and oh, that fits there. And it's like Russian roulette. I've seen them where they can't get them in spec and they gotta send it out and have the counter bores all sunk. I mean, it can be a chore, yes.
So when we reassemble the motor, we'll be doing some of this
Yeah.
process right here.
Yep,
You'll have
I'm
to shim
ordering
and
up,
everything.
I'm ordering up hopefully, a sledge gauge. Actually, I'm getting my machine shop to build me one. I hope if not, I'll have to order one up. Because my other sledge gauge, somebody used it for something, not a sledge gauge, and effed it all up. Yeah, I loaned it out, and it came back all effed up. Wasn't flat. The bolt hole was stripped that holds the gauge in. It'd been peened, somebody hit it with a hammer. So I'm like, gee, man, Christmas, are you kidding me?
Like animals and eating food.
Hey Mike, can I add one more thing on that? Oh, you gotta check it at like 4 locations to make sure that it's not leaning in the board.
Yeah, there's places at Cummins and Detroit, Mac and Cap wants you to check, and it's like 10,000ths of an inch.
Yeah.
Between-
It's around.
Yeah, around. Because that way, if my counterboard's crooked, I don't want my cylinder leaning. Okay. Now, we check our cylinder obviously for taper and out of round. So that's a taper when the top measurement is less than the bottom measurement. Okay. Now, if I'm buying a new cylinder, a new liner, I probably would just do a random check of 1 or 2 of them, just to make sure. Because just because it's new doesn't mean it's good. Much as I hate to say that. Okay.
Who got scared when he said random?
And, yeah, random. Out of round, now you see it's checked in 4 spots. Actually, most engine manufacturers will want 6 checks. Here, 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 and here, kind of like a pizza. 6. To make sure that it's round, or the roundness of it is within spec. Okay? And oftentimes, you'll go to rebuild an engine, you'll pull the liners out of it, and you'll measure the parent cores, and we're good to go. Hey, they're a little out of round, and they're a little tapered, but it's within spec of the engine manufacturer, and the deck is flat, and the block height is correct. I don't need to machine this beast. I can go ahead and use it as is. Do people do that? Absolutely. Saves downtime, saves cost. Okay, now when we look at the crankshaft, okay, this is the critical, this is the heart of the beast. Okay? If the crankshaft is faulty, and we'll talk about faults here in a minute. Doesn't matter what you do with the rest of the block, if that thing goes, if that crankshaft fails in service, you've wiped out the entire engine. Okay? So one of the things that you don't want to do is put any right angles on that crankshaft. Now, where might there be a right angle on it?
Edges.
Well, the journal to the counterweight. The holes in the crankshaft are not at right angles. They're tapered. It's a chamfer. Okay. So if this is my counterweight, there's going to be a radius here. And if this is my oil hole, there's going to be a radius there. Right? If I put any kind of a sharp angle in here, I've built in a stress riser. And a stress riser is just simply a right angle in the surface. Maybe it doesn't penetrate all the way down. Now I made a cut on my pencil. Took my knife. Now if I look at that cut under a microscope, so I've got some right angles there, right? Pretty clean break, isn't it? That's a pretty clean break. And all I did was etch. You can tell how deep I went. Not very. Okay, that's how deep I went. I didn't go very deep. And you saw how that failed. Okay. If I machine my block, or I machine my crankshaft, that's actually, if you ever watch a brick mason, that's how they cut bricks. He etches the brick, lays it over the edge, and he taps it, and just right across it. Because that etching puts a stress riser in the brick.
Less wear on the machine that cuts it.
It just snaps. Okay, it's relatively clean brick. Okay. Now, if you look at the specifications on a crankshaft, they'll have what they call a specified radius. In other words, radius is a measurement of an arc or a circle. And there'll be a minimum and a maximum radius. So when I machine my crankshaft, this will have a certain roundness to it as opposed to a straight edge. And so you'll have ball gauges of specific radiuses that you can measure against it. So if I put a ball gauge in here and it fits in here snug, whatever size ball gauge that is, that's the size of that radius. Okay, if it's too tight, it could set up a stress riser. If it's too loose, it's probably not flat. Okay? So the crankshafts for our world in heavy duty are forged steel. So they take a piece of steel, they heat it up red hot, and they basically press it into shape. They just beat it into shape. If you've ever watched a crankshaft get built, they'll have this smoking hot round stock steel. Bing, bing, bing with a press until it looks kind of like a crankshaft. Then they send it out to machine shop and they machine all the surfaces on it. They'll drill it, drill the required holes in it, and then they'll balance it. So those big dark sections of that crankshaft where you see the polished sections, those are the counterweights. And in those counterweights you'll see, not holes, but you'll see recesses in them where they've taken metal out of it. That's how they balance it. Okay. Why don't we take about 15 minutes? Take a breather.